So if you have these key 5 identities memorized, then you can do a lot of things. We've already mentioned how if you know this one, you can divide both sides by cosine squared to get 1 plus tangent squared equals secant squared, or divide both sides by sine squared to get cotangent squared alpha plus 1 equals 1 over sine squared is going to give you cosecant squared. So that one's handy for these. You can get lots of other identities from these angle sum and difference ones together with the Pythagorean identities. One example would be the cofactor identities that we just mentioned. For example, if you looked at the cosine of pi halves minus alpha, that actually fits this first formula, right? You'd get the cosine of the first angle and the cosine of the second angle, which is alpha. Since it's a minus sign here, we use the plus the sine of the first angle times the sine of the second angle. Now, the cosine of pi halves is 0, so 0 times cosine alpha is just going to be 0. The sine of pi halves is 1, so we'll get 0 plus 1 times the sine of alpha. So just from knowing this angle sum identity, you got the cofactor identity. You could also get the other cofactor identity for sine here. The sine of pi halves minus alpha, using this formula, would be the sine of the first, so the sine of pi halves, times the cosine of the second, so the cosine of alpha. Since there's a minus sign here, we're going to use the minus sign, because those go together. So minus the cosine of the first, which is pi halves, times the sine of the second, which is alpha. But the cosine of pi halves is 0, and the sine of pi halves is 1. So we get that other cofactor identity, cosine alpha. So that's one illustration of why these key 5 can lead to all the identities that you need. Here are some that come from these key 5 that were going to be pretty important to us. What if we had the cosine of 2 times some angle? We could think of that as the cosine of the first, the cosine of alpha plus alpha. Let's edit this guy. Okay, and we'll start again. What if we were interested in finding the sine of 2 times some angle that we knew about? So 2 times alpha is the same thing as alpha plus alpha, so we can apply the formula for the sine of a sum. According to this formula, you get the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. But the first and second angle in this case, they're both alpha. So you can multiply in any order, so those could be switched. So basically you have 2 times sine alpha cosine alpha. Okay, well, that's kind of handy. If we wanted, we could look at an example of using that. Let's see, what's the sine of 120? Well, we could count in, but we could also use our formula here. That's the sine of 2 times an angle I'm really familiar with, 60 degrees, right? Which would be 2 times the sine of 60 times the cosine of 60. And the sine of 60 degrees is root 3 over 2, and the cosine of 60 degrees we know is 1/2. And so we get, let's see, those 2's cancel, we get root 3 over 2. Okay, well, we could have figured that out just by saying to ourselves, all right, well, here's 30, 45, 60, 90, 120. 120 is right there, right? Then 135, 150, and 180. And we know we're looking for the sine of that angle, right? And so we have square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. And same thing coming back down here, right? The sign would be the same. So we could have used our little memorization pattern to get that one, but that's kind of fun. We'll see there's another more important application that comes if we do this with the cosine of 2 alpha. So again, that's the cosine of alpha plus alpha. And if we apply this angle sum formula, we get the cosine of alpha times the cosine of alpha minus the sine of alpha times the sine of alpha. So the cosine of 2 alpha is equal to cosine squared alpha minus sine squared alpha. That's handy. It's even more handy if we use our Pythagorean identity. According to the Pythagorean identity here, the cosine squared is 1 minus the sine squared. So we could replace cosine squared with 1 minus sine squared. We've got this other minus sine squared, and so we get 1 minus 2 sine squared alpha. So, or if we look at this 1 minus sine squared, if I take 1 away here from the Pythagorean identity, cosine squared alpha minus 1 is the same thing as minus sine squared alpha. So this cosine squared is 1, let's see, this is cosine squared alpha, and then the minus sine squared is another cosine squared alpha minus 1. So we get 2 cosine squared alpha minus 1. These two are very useful in calculus. Let me just rewrite them here. The cosine of 2 alpha has two forms. One form involves cosine, so it's 2 cosine squared alpha minus 1. And the other one is that the cosine of 2 alpha is 1 minus 2 sine squared alpha. We got that by using the angle sum formula for cosine together with the Pythagorean identity so that we could write everything in terms of either cosine squared or sine squared. This is useful because we could solve this for cosine squared. If I add 1 to both sides, I get 2 cosine squared alone here is equal to 1 plus the cosine of 2 alpha. Now just divide both sides by 2, and I see that cosine squared alpha is 1 plus cosine 2 over alpha, all divided by 2, or you could write it this way as well. Cosine squared is 1/2 plus 1/2 cosine 2 alpha. We'll see that this is a very handy identity. What it does is it reduces the power on the cosine. So instead of having cosine squared, now we just have a plain cosine. So that's a very useful identity. We could do something similar here. Let me move the 2 sine squared alpha over here by adding it to both sides, and I'll move the cosine 2 alpha here by subtracting it. So I get 2 sine squared alpha on one side and 1 minus the cosine of 2 alpha on the other. Now divide by 2, and we get 1 minus the cosine of 2 alpha all over 2. Or we could write it this way. Sine squared alpha is 1/2 minus 1/2 cosine 2 alpha. So if you want to change a cosine squared into something about cosine, then you just take 1/2 plus 1/2 cosine 2 alpha. If you want to change a sine squared, it's 1/2 minus 1/2 cosine 2 alpha. So we got those just by knowing our formula for the cosine of a sum. From there, it was easy to get those two identities. So if you'll memorize these key 5 and just a few tricks, you can follow your nose to identities that you need.